Okay, studying out for test 3, systems. All right, so we're going to solve each system. Since we have two equations that are in standard form, we want to eliminate one of the variables. So we can kind of go through, and I always like to ask this question when I do it. I look to the smallest variable. So here I have a 2x versus a 4x, and I ask myself, is there a number times 2 that can get me a 4? The answer is yes. I go to the 5, which is smaller than 10. Is there a number times 5 that gets me 10? Yes. Since it's yes to both of these, I can choose if I want to eliminate the x's or the y's. Now in this problem, I'm going to eliminate the y's because I see that the top equation has a minus 10y and the bottom is positive 5y, which means all I need to do is multiply by a positive number for these two to eliminate. So I'm going to multiply the bottom by 2 because 2 times 5 is going to give me 10. So my first equation stays the way it is. My second equation will become 4x plus 10y equals 18. Now I have 4y plus 4y, that is 4x plus 4x is 8x. Negative 10y plus 10y is 0. 18 take away 2 is 16. Divide both sides by 8, and we learn that x is 2. From there, pick any equation you want, plug it in, and solve for y. I'm going to go ahead and pick the second equation, the 2x plus 5y equals 9. I'm going to plug the 2 into the x, and I'm going to solve. And minus the 4. And divide by 5. And so our point of intersection is 2, 1. Our second problem, we're approaching it the same way. We've got a system in standard form, so we want to see if we can eliminate any of the variables. So I go to the smallest x, 3. Is there a number times 3 that gets me 4? No. I go to the 5. Is there a number times 5 that gets me 6? No. When it's a no for both, this is when you need to multiply twice. Now in this problem, I can see the y is positive in the top equation and y is negative in the bottom. So I'm going to get rid of the y's since the signs are already opposite, which will make it a little easier. So I'm going to go ahead and multiply the top equation by a 5 and multiply the bottom equation by a 6. That's going to create positive 30 and negative 30, so they'll cancel out. So the first equation is going to have 15x plus 30y equals negative 15. The bottom equation is going to be 24x minus 30y equals 54. Okay. And then we have 15x plus 24x is 39x. The y's are going to equal 0. 54 minus 15 is 39. So divide both sides by 39, and we learn that x is 1. Now that we know what x is, plug it into any of the equations you want, and you're going to find the y value. I'm going to do the first equation. And we know the x is 1 now. Now we're just going to go ahead and solve. And our answer is 1, negative 1. Okay, so this system, we'll see that one of the equations is equal to y, which means substitution is probably the easier method to use to solve this one. So since y is negative 2x minus 8, wherever I see a y in the other equation, I'm going to turn it into a negative 2x minus 8. So it's going to look like this, 5x minus 3, but instead of writing y, instead I'm going to fill in with negative 2x minus 8. That equals negative 20. All right, and now I'm going to go ahead and just kind of solve it out. Distribute the negative 3. I have positive 6x, positive 24. All right, combining like terms to make 11x equals 24 equals negative 20. Minusing the 24 over. So 11x equals negative 44. Dividing both sides by 11, so x is negative 4. Now that I know what x is, I can plug it back into the equation that's equal to y to find out what the y is. So, looks like it's going to be 0. So we have negative 4 comma 0 as the point of intersection. All right, so we have a 3-variable system, and to handle this, we're going to have to do a lot of elimination. When looking at this problem, I like to label my equations. This is equation 1, equation 2, equation 3. So looking at the problem, it looks like right here, the equation 1, equation 2, the z's could cancel out. So I'm going to start off my problem by canceling out the z's, and I'll solve for those later on. So equation 1 is going to get matched up with equation 2. Now when I do that, I can see that the two z's would make 0, so that's why I can cancel them out. I'm going to get a 5x, a negative 3y equals a negative 2. And I kind of want to make another equation that is an x, a y equals a constant. So I have to go back to my original 3, and now I'm going to need to cancel out a z again with a different combination of equations. So I can see that here, equation 2 has negative z, and equation 3 I have 3z. I'm going to make those cancel out. So I'm going to pick equation 2 and equation 3. All right, so I need to multiply the top equation by positive 3. And watch what happens when I do that. I'm going to get a 9x, a 6y, a negative 3z, and negative 6. I just distributed the 3 to all the terms in the equation. My bottom equation is going to be negative 6x, 3y, positive 3z equals negative 6. Now when you look at it, you can see that positive 3z and minus 3z makes 0. So those are going to cancel out. And so now we're going to have 3x plus 9y equals negative 12. So now I have a system where I just have x and y. Well, I can take those and I can solve them like we were doing in the previous problems. So I have 5x minus 3y equals negative 2. And I have 3x plus 9y equals negative 12. Now with these two equations, I want to go ahead and eliminate one of the variables. So when you use that skill from earlier, I'm looking at the 3. Is there a number times 3 that gets me 5? No. Is there a number times 3 that gets me 9? Yes. So eliminating the y's in this problem would be the easiest thing to do. So I'm going to go ahead, I'm going to multiply the top equation by 3. When I do that, I'm going to get 15x minus 9 equals negative 6. And my bottom equation stays the way it is. And now you can see that when I try to solve this, the y's are going to cancel out. So I'm going to have 18x equals negative 18. So when I divide, x is negative 1. Now that I know what x is, I can go back to one of the equations up here, plug in to find y. So I'm going to do that to the red equation. So I have 5 times 1 minus 3y equals negative 2. So 5 minus 3y equals negative 2. I'm going to go ahead and minus the 5 over, so I get negative 7. So I have negative 3y. Going to divide both sides by negative 3 is going to give me positive 7 over 3. I just want to double check, make sure I didn't make any mistakes. Oh, I see my mistake. I noticed that the x was negative 1, but when I wrote my problem, I put a positive 1. So that's going to change a few things. That's going to make that negative 5. This is going to make it positive 5 when I add it over. So I'm really going to end up with positive 3. So when I divide by negative 3, I'm going to get negative 1. So my x is negative 1 and my y is negative 1. So I need to go back to one of the original problems. I need to plug in the x and the y to find out what z is. I'm going to do that to equation 1. So I have 2, I'm going to plug in the negative 1, minus 5, the y is negative 1, plus z equals 0. So this is going to give me -2, positive 5, z equals 0. It's going to give me 3 plus z equals 0, minus the 3 over, z is -3. So our answer in alphabetical order is -1, -1, -3. All right, so another one of these 3 variable systems. Once again, I'm going to label my equations. This is 1, 2, and 3. So once again, looking for variables to eliminate, it looks like the z's would be the easiest one. Again, it's not always z, it just happens to be that way in these problems. I have a -5z and a positive 5z, so equation 1, equation 2 can eliminate the z's. Oops, that should be a 3x. There we go. All right, so this time the z's are going to cancel out. We got 5x, -3y equals 36. Once again, we want to pick 2 equations that can let us eliminate z's. It looks like we are going to need to do, we're going to do 2 and 3. The signs are opposite, so we just do a little multiplication, but at least the signs are opposite for us. Now we can see that 5z and 2z, 2 can't multiply to make us a 5, so we're going to have to multiply twice. I'll multiply the numerator, the top equation by 2, multiply the bottom equation by 5. So I'll have 4x plus 2y equals 10z equals 40. The second equation, 25x plus 15y minus minus 10z equals 100. So here the z's are going to cancel out, so I have 29x plus 17y equals 140. So now I have 2 equations that are x and y. So now I can set them up as a system and solve those. Oops. All right. So now, numbers are going to be a little annoying. So I'm going to get rid of the y's because one's positive, one's negative. So I'm going to multiply the top by 17 and the bottom by 3. Okay, so 17 times 5 is 85x. 17 times -3 is -51y. 36 times 17 is 612. And then second equation, 3 times 29 is 87. 3 times 17 is the -51y. 3 times 140 is 420. Oops, that's positive 51. All right, those are going to cancel. 85 plus 87 is 172x. 612 plus 420 is 1032. Divide both sides by 172. We're going to get x is equal to 6. Now that we know x is 6, we can plug back into one of the equations up here to find out what the y is. I'm going to choose the top one, 5 times 6 minus 3, y equals 36. So that's 30 minus 3y equals 36. Minusing the 30 over, I'm going to end up with 6. Dividing both sides by -3 gives me -2. Now that I know what x and y is, I'm going to go ahead and plug into one of the original problems and solve for z. I'm going to go with, I guess equation 2 seems like the numbers are not terrible. So 2, once again using equation 2, 6 is x, plus -2 is the y, plus 5z equals 20. So I get 12 minus 2 plus 5z equals 20, which means that's 10 plus 5z equals 20, minusing the 10 over, I'm going to get 10, dividing by 5 gets me 2. So in alphabetical order, 6, negative 2, positive 2. All right, so now we're doing systems with a linear and a nonlinear. And it asks us to check for extraneous solutions, which we'll need to do because we have the square root equation. We're going to set them equal to each other. So the square root of x plus 3 equals negative 2x plus 4. We set them equal to each other because both equations are equal to y, so you can set them equal to each other. Now we're going to go ahead, get rid of the radical by squaring both sides of the equation. That's going to cancel out, leaving x plus 3. Once again, how we multiply this in our head, negative 2x squared is going to give us positive 4x squared. Negative 2x times 4 is negative 8x, but then we double it to make negative 16x. 4 squared is 16. Once again, that's how you multiply in your head. Once again, you could always use a box to multiply it out, and you'll get the same thing when you do that. All right, so now I have an x squared and an x. I'm going to move everything to the same side. So I'm going to minus an x over. I'm going to minus the 3 over. That's going to leave me with 4x squared minus 15x plus, that'll be minus 17x plus 13 equals 0. I have a 4, a 17, a 13. They don't have a greatest common factor, so I'm going to go ahead and go straight to the box method of factoring. So 4x squared, 13, negative 17x. 4 times 13 is 52x squared. So we got to think of two numbers that multiply to be 52, but would add or subtract to be 17. Just checking some numbers. Found one. 4 times 13. So 4x, negative 4x times negative 13x. So negative 4 times negative 13 would make the 52. Negative 4 plus negative 13 makes negative 17. All right, now for the values on the outside, I think I'm going to go with this being 4x times x makes 4x squared. And that's because 4x times negative 1 would make negative 4x. X times negative 13 would make the negative 13x. So now I've got my quadratic written as x minus 1, 4x minus 13. That's going to give me x equals 1, because what number minus 1 would equal 0? Positive 1. Going with that same question, what number times 4 minus 13 would equal 0? You can do that mentally. Remember, it's going to be a sign switch for the 13, so it's positive 13. The number in front of x will end up in the denominator, so it's positive 13 over 4. Now that we have the x's, we do need to find the y's, so I'm going to plug them into the second equation here. So I'm going to plug in the 1 first, so negative 2 times 1 plus 4. So that's negative 2 plus 4, that is positive 2. So one point of intersection is 2, 1. Then for the other, negative 2, 13 over 4 plus 4. All right, so that's going to cancel, getting us negative 1 on top, 2 on the bottom. So negative 13 over 2 plus 4. I'm going to use my calculator to get the decimal of that, I guess. Negative 13 divided by 2 plus 4. I'm getting negative 2.5 as to y. So we have 13 over 4 comma negative 2.5. So these are 2 points of intersection, but we do need to check for extraneous. So I'm going to plug my first one in. So y2 goes into the y, and 1 goes into the x. It's going to give me the square root of 4. Square root of 4 is 2, so that makes sense. Plugging into the second one. 2, negative 2 times 1 plus 4. That gives me 2, so that makes sense. So this is definitely a solution. Checking our next one, our y is negative 2.5 equals the square root of 13 over 4 plus 3. Now 13 over 4 plus 3 is going to give me a positive number. When I square root, it's still a positive number, so it's never going to equal a negative 2.5. So just as a reminder, 13 divided by 4 plus 3 is the square root of 6.25. And the square root of 6.25 is positive 2.5, which is not equal to negative 2.5. So that one is our extraneous. Okay, another one. We got two quadratics this time. Asked us to solve and then check for extraneous. So they're both equal to y, so we can set them equal to each other. So from here, I'm going to move all my x's to one side. I'm going to add this 1x over, add the 2x minus the 14. And end up with 2x squared minus 2x minus 24 equals 0. This time I noticed 2, 2, and 24, they have a greatest common factor of 2. Now I can go ahead and factor with my box. The numbers should be pretty easy this time. Two numbers that are going to multiply to be negative 12, but combined to be negative 1. Negative 4x and 3x would work. So x, 3, negative 4. So we have x minus 4, x plus 3. Zero product property, what number minus 4 would equal 0? Positive 4. What number plus 3 would equal 0? Negative 3. Now that we know the x's, we do want to plug in to find those y values. All right, so 4 equals x squared. Oops, that is totally not what I'm doing. Y equals parentheses 4 squared minus 4, 4 minus 10. So 16 minus 10, those equal 0. So negative 10 is the y. So one point of intersection is 4, negative 10. I plug in the negative 3. So we get 9, positive 12 minus 10. So 2 plus 9, 11. So negative 3, 11. And I'm not going to show it on here, but because I don't have the room. But if you plug these into both equations, both of these coordinates are going to work if you substitute them in. So no extraneous this time. All right. Number 9, they give us two equations. I'm going to take this y equals 2x plus 12. I'm going to plug it into the y into this other equation. So I have x over 2x plus 12 equals 1 over 8. I'm going to cross multiply to solve this problem. So 8 times x is 8x. 1 times 2x plus 12 is just 2x plus 12. I'm going to solve for x, going to minus the 2x over. That gives me 6x equals 12. Divide by 6. X is 2. Now that I know x is 2, I'm going to plug it in and get the y value. So y equals 2 plus 12. That's 4 plus 12. That's 16. So our point of intersection is 2, 16. Checking for extraneous, you can just kind of plug them in. 16 equals 2, 12. That's 4 plus 12. That's 16 equals 16. Makes sense. Next one, we got 2 over 16 equals 1 over 8. You can reduce 2 over 16 to 1 over 8. So that works. So this is a solution. Our next one, doing the same thing. We're going to take this minus x plus 5 and plug it in. So we have x over negative x plus 5 equals 2/3. Cross multiply. So we're going to have 3x. We're going to have 2 times negative x plus 5. So that's negative 2x plus 10 equals 3x. Solving for x, I'm going to add the 2 over. That's 5x equals 10. Divide by 5. The x is 2. Plug it in to find the y. So we have -2 plus 5, the y is 3. So our point of intersection is 2, 3. Going to check for the extraneous, going to plug it in. We got we got 3 equals negative, and then we plug in the 2, 5, that's 3 equals 3, makes sense. 2 over 3 equals 2 over 3, makes sense. Solution. All right, so here we've got two equations. They both equal y, so we can set them equal to each other. So I have the square root of 4 equals 8x times 1/4 x plus 4. On the left side, the square root of 4 is just 2, so technically it's 2 to the first. The 8 and the 4, I want to make them like bases. I'm going to turn 8 into 2 to the third power. I'm going to change 1/4 into 4 to the -1, which is x plus 4. They're still not the same, but I can change the 4 into 2 squared. And since it already had a -1, that's just going to be -2. All right, so now that the bases are the same, I can actually combine these here to the right. If it's times, we add the exponents. So we have 3x plus -2 times x plus 4. And the other side, it will equal to 1. So now I can distribute -2x minus 8. 3 take away 2 is just x minus 8. Add the 8 over, so x is 9. Now that I know x is 9, I can go ahead and plug in to find the y. So y equals 8 to the 9th times 1/4, 9 plus 4. So we have what, 1/4 to the 13, 8 to the 9. I'm going to use my calculator for this. We get the number 2. So 9, 2. Plugging it back in, you plug a 2 in for the first one where you have y square root of 4. That y is 2, square root of 4 is 2. That works. If you plug a 9 into the second problem, which is what we did here, we did learn that the y is 2, so we've technically checked that point, so we know that is going to be a solution. All right, problem 11. This is one of our review problems. Once again, vertical asymptotes, holes, all that kind of stuff. Starting for the hole, the x plus 3's cancel out, meaning there's a hole at x equals -3 for its x value. Now, if you got, anyone but me, they also had you find the y value, and the way you would find the y value of the hole is that you take the -3 and you plug it into the remaining equation. So to find the hole's y value, you're going to have -3 minus 4 over -3 minus 1. Once again, I'm just taking this leftover part of the equation. That's going to give me -7 over -4, which is just 7 over 4. So the coordinate for the hole is technically -3, 7 over 4. Vertical asymptotes, there's only one. It's x equals 1. It comes from the bottom. The x-intercept is x equals, is going to be 4, 0, and once again, that comes from the numerator. Horizontal asymptote, they're the same degree, their leading coefficients are 1, so it's y equals 1. So doing some graphing, vertical asymptote is 1, horizontal is 1, x-intercept is 4. We have a hole at -3 and 7 over 4. 7 over 4 is 1.75. So we have a hole about here. Graph. Domain X is an element of all real numbers, but it is not going to be the vertical asymptote or the whole, so it's not going to be 1 or -3. Range, y is an element of all real numbers, but it's not going to be the number 1, the horizontal asymptote, or the y value of the whole. Sorry, 704. Okay, our last problem. Another review question. We're going to factor the denominators. They have an x in common down here. So I need to multiply by an x and an x minus 6 to cancel everything out. So here the x minus 6 cancels x minus 6, leaving 1. Here the x minus 6's cancel, leaving the x and the x minus 4. Then we have our minus sign, cancels, leaving 4. Okay, we're going to distribute x squared minus 4x minus 4 equals 1. We're going to minus the 1 over because if you have an x squared and an x, you want everything on the same side so you can factor. Now we're going to go ahead off to the side, use the box to factor it. X squared minus 5 minus 5 squared. Okay, two numbers that multiply to be -5, but will combine to be -4 would be -5x, 1x would be our proper combination. So our x-intercepts are simply going to be, well, our solutions are simply going to be 5 and -1. We do need to plug in the check for extraneous, which is always annoying. So plugging in, we don't actually have to plug in. Once again, our extraneous will be the excluded values. In this problem, excluded values are going to be 0 and +6, which are none of our solutions, so we know those are answers.